In this video, we're going to find the derivative of a function at a particular point using the limit definition. And we actually have two formulas for that, and so we're going to do it both ways. All right, and the function I want you to find the derivative of is x squared plus 1, and I want you to find the derivative at the point x equals 1. So find f prime of 1. That means take the derivative at the point x equals 1. So remember, when we're using the limit definition, the 1 is going to represent our a. Okay, so we just start filling in the formula. The limit as x approaches a, and in this case, the a is 1. So then it's f of x, and f of x is just x squared plus 1, minus f of a. And remember what f of a means. If I asked you to find f of 2, you would plug 2 in wherever there's an x, and you would calculate that. So we want f of a, and in this case our a is 1, so we're going to find f of 1, and that's going to be 1 squared plus 1, which is 2. Okay, and then that's all going to be over x minus a. Again, a is 1. So now it's just a matter of simplifying. So we get the limit as x approaches 1 of x squared, and then this is plus 1 minus 2 is going to be minus 1, and that's all over x minus 1. And then remember, when we take the limit, if we plug x equals 1 in here, we're going to get 1 minus 1, which is a 0, over 1 minus 1, which is another 0. So this is the indeterminate form. And remember, we have a couple of different ways that we can take the limit, and one of those ways is the algebraic way, and we try factoring, and we know that x squared minus 1 can be factored into x minus 1 times x plus 1, and then we have that over x minus 1. And then the good news is these two factors cancel, and so we take the limit as x approaches 1 of x plus 1, and we get the answer of 2. All right, so that's the first way to do it. The second way is to use the formula, the limit as h approaches 0 of f of a plus h minus f of a all over h. And so a, again, is 1, and we don't have a value for h, so we have the limit as h approaches 0. And we're finding f of a plus h. Remember what that means. That means you're going to take a plus h and plug it in for x wherever there's an x. So our a is 1, right? Remember, a equals 1. So a plus h would be 1 plus h. And so I'm going to take 1 plus h, and I'm going to square it, and then add 1. And then we're going to subtract f of a. And again, we had calculated f of a last time, and we got 2. So we're going to subtract 2. And that's going to be all over h. So we simplify, and we get 1. We multiply that all out, and we're using the FOIL method. Remember, 1 plus 2h plus h squared plus 1 minus 2 all over h. Again, keep simplifying, so we get 1. I'm adding all the constants. 1 plus 1 minus 2 is going to give me 0. And so all that remains is 2h plus h squared all over h. And then I can factor an h out in the top. So I get h times 2 plus h all over h, and cancel those. And I get the limit as h approaches 0 of 2 plus h. And again, now I can use direct substitution. I plug h equals 0 in for h, and I get just 2. So my answer is 2. So we just calculated the derivative using the limit definition, and we did it two different ways, and you don't have to do it both ways. You can just choose one way and use that. But let's talk about what that meant. We got an answer of 2, and the 2 represents the slope of the curve at the point x equals 1. Okay, or in other words, the slope of the tangent line. And here we have the tangent line drawn, And if you look at it and you calculate it, the slope of this line using your traditional way of calculating rise over run, we can see that it goes up 2 units for every unit that it goes over to the right. So it has a slope of 2.